I'm going to let h be equal to r sine theta minus alpha according to what the question wants. And what I'm going to do is I'm going to expand this using trivial identities. It is going to be r sine theta cosine alpha minus away r cosine theta sine alpha. And if I were to compare both sides, sine theta and sine theta, tells me that r cosine alpha must be equal to 5. This I'm going to call it equation number 1. And comparing cosine theta and cosine theta, it tells me that r sine theta alpha must be equal to 1. So r sine alpha is equal to 1. Two equations with two unknown r and alpha. I'll be able to solve them simultaneously and get the values of r and alpha. Let's try to find r. To find r, I'm going to take the first equation, square it, add it to the second equation, and squaring that too. Because by doing so, what I have is going to be 1 square, here will be r square, cosine square alpha, 2 square, that means I'm going to add it to r square, sine square alpha, and on the right hand side, it is going to be 5 square plus 1 square. If I were to factorize out r square, I will get a cosine square alpha plus sine square alpha is equal to 5 square plus 1 square. And what is cosine square alpha plus sine square alpha? It is equal to 1. So r square is going to be equal to 5 square plus 1 square. I know what is r now. R is going to be square root of this, which is 26. And to solve for alpha, I'm going to take equation number 2 and divide it by equation number 1. Which means that it is going to be r sine alpha divided by r cosine alpha. This is 1 over 5. And doing so, on the left hand side, r and r will disappear and sine over cosine is tangent. So tangent alpha is 1 over 5. And alpha is going to be equal to tangent inverse of 1 over 5. Since alpha is an acute angle that is given to us by the question, and this is equal to 11.3099 degree. So this tells me that h can be re-expressed as r, which is square root of 26 sine of theta minus alpha, giving it to just 3 significant figure. This is 11.3 degrees.